Peshkin and Susskind, and it effectively says that if I have a Lindblad equation, and the Lindblad equation is a local field theory Lindblad equation, so something like let me, it looks like this minus, so this is like a typical, so these are field operators. So that's a Lindblad equation integrated over dx.
What do all these things mean?
So this is a field, so these are field operators, quantum field theory operators, like a scalar field, phi. And this is, say, some density matrix. Then this is the Lindblad equation for the scalar field, for example, or one of them. They argued that if I have such a thing, then it will lead to a huge violation of energy and momentum conservation. Because these things are kind of acting very locally. You can think of it like you are measuring the density you're measuring a density matrix in position space, in position, and that will violate momentum conservation. So there's some argument you can make that local field equations will lead to a violation of, clearly you will violate energy conservation because the generator, so you have a time symmetry here still, but you don't have a Noether's theorem because you don't have a unitary evolution. So time symmetry does not lead to energy conservation. So you could violate energy conservation, and you can say, that's fine, I don't have a Noether's theorem, I don't need to conserve energy, but you at least need to make things that look like the world we see around us. So any energy violation should be small, or at least the vacuum should be stable.
Is it obvious that the energy variations of that thing are not small and should be?
I think there's many ways of making them small, and I think there's even ways of getting around it. So I think this is a fruitful area of research. The other reason is that if you believe in ADS-CFT, then you're believing in unitarity. So because on the CFT, I just have a conformal field theory which is evolving unitarily, and so that's a unitary theory. Now I think one could say a lot about that, and I won't do that. But those are the two arguments against it. There's probably another one which is, well, if I take some non-unitary theory, then I can always purify it, so why not just look for the pure theory anyway? That's another one, but again, I think there's...
Not all non-unitary things can be purified like that, right?
Yeah, I would agree with that.
So this is another area. So if we knew what quantum gravity was, we just have an answer, and the set people debate priors what it should be like.
What are constraints on what?
I'm not sure what...
You said, like, if you have no unitary theory, you can purify it. But then, like, the evolution of the unitary evolution of the purified theory, like, will it still be local, and or it will be something very strange?
Yeah, so I believe that you can make theories which, when you purify, don't make sense, or at least would not. I mean, you could still always do it, but it would be a weird theory. So I think it's reasonable to look for non-unitary theories. I don't regard any of these three arguments as being decisive. I guess I would say that I feel a bit of what the game is, that we are declaring ourselves, we're declaring that this is a no-go, that these non-unitary theories are a no-go because of Banks, Peshkin, and Susskind, for example, or whatever. And then we're hanging on to unitarity, and we're willing to make any kind of sacrifice to the laws of physics in order to hold on to unitarity. So we're willing to give up the equivalence principle. We're even willing to make things non-linear, which feels like even worse than giving up unitarity. So we're even giving up, like, we give up linearity a lot. I think in ADS-CFT you're often giving up linearity. So I feel people sometimes give up on these theories and are willing to accept a lot more in order to hang on to unitarity. But it's a very minimal opinion, so I probably shouldn't be giving this tutorial.
Minimal minority.
Sorry?
Minimal or minority? I mean, do you hold it weakly, or you're just saying you're one of the...
No, I hold it strongly, I think.
So what about the idea that, as a solution to the information paradox, that this is an idea I get out of reading David Deutsch very superficially, that the Hawking radiation coming out from a black hole is random, and that the information that you dropped in went into another universe, of the multiverse. Does that make any sense?
Yeah, well, I'm not sure about multiverse, but there's definitely people that believe, that I have a baby universe. I mean, if it's going into the singularity, and I somehow have a way to cure that singularity, maybe there's another, a baby universe or something, and it.
Wormhole instead of
Yeah, a wormhole or something, and
But even just the remnant fits that
right,
story, right?
right,
even just one,
A remnant.
a remnant, yeah.
yes.
Well, a remnant, I don't like that, all that, it's very messy, it's like having
What remnant?
cigarette butts all over your apartment.
Well, it's actually worse than one of the conflicts in that it's such a small thing.
Yeah.
Why doesn't the whole universe instantly turn into those?
What you mean even after everything radiates out, there's remains still
A lot of
Yeah,
entropy
in the point?
Can I take a picture of people for Twitter for that comment? Just to. Is anyone not? Is that okay?
Go ahead.
I feel that is a good comment. Or it's good for the laughs.
Do we have time for one more question? Otherwise,
Just don't let any Russian trolls see it.
Yeah.
okay.